Welcome guys to day 2. There's actually quite a bit of review today. There's only really a couple new topics, but they're not super new. So here we go. We're going to start with a trig identity. I recommend that you pause the video and see if you can come up with this yourself. If it's been a while, I'm happy to lead you through it. We're going to start, we could go either side. I'm going to work the left side. Sin x cosine x is tangent, and cotangent is cosine x sine x. One of the things that I see right away is that this is one term. And right now on the left we have two terms. I want to make it one fraction. So I'm going to get some common denominators. So I'm going to multiply this by sin x over sin x and cosine x over cosine x. So I'm going to end up with sine squared x over sin x cosine x plus cosine squared x over sin x cosine x. Pythagorean identity is states that sine squared x plus cosine squared x is equal to 1. So I get 1 over sine x cosine x. 1 over cosine x is secant, and 1 over sine is cosecant. Great. Okay, moving on. The third slide is a review of what we did yesterday. So let's dive into these 5 practice problems. First, we're going to start. We're just going to start from the inside and work our way out. So for number 1, I see the arctan, the inverse tan, is 4/5. Positive 4/5. So I'll make a bow tie in the first quadrant. Opposite over adjacent, 4 over 5. If I do Pythagorean theorem, I get 25 and 16. I think I get the square root of 41 here. So that means the cosine, that's a theta. Here's theta. There's my triangle. So the cosine of that theta is going to be equal to adjacent over hypotenuse, or 5 over the square root of 41. Okay, let's try the next one. I think I see the sum formula for sine. Do you see that? That this could be theta 1 and that's theta 2. So I think this is sports center. I think this is the sine of theta 1 cosine theta 2 plus sine of theta 2 cosine of theta 1. And we have to figure out theta 1 and theta 2. So I'm going to back up a little bit. We'll do 2 over here. So theta 1 said that the cosine is 2 over 3. 2 over 3, which means that that missing side would be, let's do this, 2 squared plus b squared equals 3 squared. I think it's the square root of 5. 9 minus 4. Yeah, I think it's the square root of 5. Okay, and then I need to make second triangle for theta 2. And it says theta 2, the arctan is 4/3. So opposite over adjacent is 4/3. That's 16 and 9. Oh, it's a 3, 4, 5. Okay, so I'm going to use those to solve this. So sine of theta 1 is going to be opposite over hypotenuse, root 5 over 3. Cosine of theta 2 is going to be adjacent over hypotenuse. That's in theta 2. Plus, the sine of theta 2 is 4/5. And the cosine of theta 1 is adjacent over hypotenuse, 2/3. Both the denominators are 15. And I get 3 root 5. Let me give myself a little bit more room for this. I get 3 root 5 plus 8 all over 15. Number 3, similar double angle formula for cosine. Can you see that that's cosine of 2 theta 1? Okay, and we'll work over here. Theta 1. It says arc cosine is 1/3. So I'd end up with 1 squared plus b squared equals 3 squared. I think it's the square root of 8. So double angle formula for cosine would be, I'm going to use the one that I like. So I like the cosine squared theta minus sine squared theta. Okay, so the cosine of theta is 1 over 3, and then we're going to square it. And the sine of theta is root 8 over 3. We're going to square that too. And I think my final answer is going to be 1 minus 8, which is negative 7 over 3 squared is 9. Okay, last one, arc cosine of 1/2. Finally, we're getting a unit circle question. Where on the unit circle is the cosine of that theta? What radian is the cosine of that theta equal to 1/2? And I think that that's going to be at pi over 3. And then arc sine of -4. Right away, I know this doesn't work. Whenever you're taking arc sine of something, it's got to be less than 1. I know that. Second, if you weren't sure of that, if you were to draw this, it's down here because it's negative, it would be -4 over 1, so opposite over hypotenuse. That doesn't work either. So if you were to graph the sine function, -4 is down here. Doesn't cross it. So this would be a does not exist. Great. So a little bit of calculator stuff. You remember I said that your calculator doesn't have the arc sine button. The arc sine button is the inverse sine button. It's on my calculator, it's blue and it's above the sine key. So it looks like this. Number 5 would be inverse sine of 0.67. Okay, now your calculator, when I do inverse sine of 0.67, is only going to give you one answer. It's going to say that it's 0.73. Okay. Now, here's the thing. We are dealing with 0 to 2 pi. The implications of that are, let me graph a sine wave. And we're trying to figure out what radian gives you 0.67. Essentially, we're asking, let's say that this is 0.67 right here. Where are the two places that the sine curve intersects 0.67? So you do inverse sine on your calculator and you get 0.73. That's this point right here. But how do we find this point? Because your calculator only gives you one. Well, you have to think about this as a unit circle. So on the unit circle, if this is 0.73 radians, then what's this one? Well, in order to figure that out, you're going to have to figure out pi and subtract 0.73 to get to that level. So pi minus 0.73 ends up giving you, it's like 2.41. So there's two answers here. And each one, they're done a little bit differently. You just kind of have to think about the unit circle. So I've got 2. 1, 2. Let's try another one. Number 6 is inverse cosine of -0.23, so below the x-axis. So we're going to do inverse cosine of -0.23. And we get an answer of 1.80. And we're supposed to find the second one. So again, I can graph this two different ways. So I've got, let's go back. So I've got cosine. That looks like that. And I've got -0.23. Let's say it's right here. So they intersect here at 1.8. How do I figure out this one? Okay, so we've got our unit circle. 1.8, let's say, is right about here. That's kind of generous, but okay. So that's 1.8. Cosine is negative in quadrants 2 and quadrant 3. So I have to figure out this one. And to find that, I'm going to do 2 pi minus 1.8. So one full circle subtracting 2.8 to figure out the numerical value. And you end up getting 4.48. So I have two answers. Okay, let's try one more. I know these can be a little tough to wrap your brain around. Tangent, inverse tangent of 22.8. Remember, there's no restriction with sine and cosine has to be -1 to 1. Tangent goes, the range is all real numbers, so you can do the inverse tangent of any number that exists. We get an answer of 1.53. So if I were to graph tangent looks like this, right? And 22.8, let's put 22.8 up here. How many times is that going to hit the line? It's going to hit it twice. Here at 1.53, and what is that number? Well, tangent is a period of pi, so 1.53 and pi plus 1.53 gives you about 4.67. Okay. Gotta make sure I highlight these. Okay, next slide. This is more of the same calculator practice. I think we're good. Let's do. Oops. And what is on to the next? Okay. Besides the calculator part that we had just done, example 2, that's the new stuff. I actually saw it on a calculus test a couple months ago, and the kids definitely had forgotten how to use that notation. So number 1 is old, number 2 is new. We're going to do both, and I'm going to actually expand it a little bit. So the first part is just, can you solve for x? So to solve for x, I'm going to do inverse cosine of both sides, where on the unit circle is the cosine of that radian equal to √3/2, and I think that answer is at pi/6. Okay, so let's alter the question. Let's say, what if it said find all solutions between 0 to 2 pi? Okay, so all of the answers between 0 to 2 pi, that means x is pi/6, and cosine is positive in quadrants 1 and quadrant 4, so x is also equal to 11 pi/6. Okay, number 3, find all solutions. Since cosine goes on forever, how many times does that horizontal line intersect? So at pi/6, it's going to intersect at pi/6, and then every time it hits pi/6, well, pi/6 happens every go around the circle. Circle is 2 pi, so I'm going to use this k to show that it's going to be at every pi/6. As every time you go around the circle, whatever k is, positive or negative, it will always land at pi/6. And we'll do the same thing with 11 pi/6. Now, this isn't the only way to write it. You could have written just pi/6 and wrote pi k. But I'm going to write them separately. 2 pi k. Okay, so let's try the second one. The difference is that this time it says cosine of 2x equals √3/2. What happened is that if you remember, this 2 is the b, and this makes it a horizontal compression of a half, which means that I'm going to have double the answers. Because if I'm going from 0 to 2 pi, now I have 2 periods of cosine from 0 to 2 pi, and I'm looking to see where it's going to intersect √3/2. Well, that's going to happen 4 times. So let me show you how to do that. We're going to take, we're going to do inverse cosine, which leaves 2x over on the right-hand side. And then we take the inverse cos of √3/2. So now 2x equals pi/6, which means that x equals pi/12. Now let's move to part 2 and say find all the answers between or on the interval of 0 to 2 pi. Okay, so what I'm going to do is I'm going to set, I'll go back to my original. Inverse cos √3/2. And I'm going to find all the places on the circle where cosine is equal to a positive √3/2. And that's going to happen at pi/6. It also happens at 11 pi/6. So I'm going to set both of those answers equal to 2x and then divide by 2. And I get pi/12. And I get 11 pi/12. Okay, last step is to know that the period of this function is equal to, if I take the b, I get pi. So it's going to happen at pi over 12 plus another pi, which would be 13 pi over 12. And it's going to happen at 11 pi over 12 plus another pi, which would be 12 over 12 plus 11. That'd be 23 pi over 12. Now I'm going to look at my very last answer, and I have to ask myself, if the interval goes from 0 to 2 pi, I just want to check my answers, are all of those answers less than 2 pi? And my biggest answer is 23 over 12, which is just a little bit less than 24 over 12. So that means that I like all 4 of those answers. Okay? And then in the end, the last question, when we ask all of the possible answers, not putting any intervals on it, all, we would say that pi over 12 is one of our answers plus pi k, and then 11 pi over 12 is one of our answers plus pi k. Great. Aren't any practice of these on this particular homework, but it is coming up. Problems are okay. So we've arrived at the homework. Unfortunately, on this homework, this homework focuses on the first skill that we had at the beginning of the lesson. So maybe I'll pick a couple of these and do them with you. Like maybe I'll do 135. So again, working inside out. I picked this one because it's a cosecant, and we haven't, I don't know if we've done that, but let's pretend that we haven't. So we're going to do arc cosecant -3. Cosecant is cousins with sine. So -3, remember that's like -3 over 1. So that would be opposite over hypotenuse. So that would mean that this is hypotenuse over opposite. And I'm going to make that 1 a negative. And then I need to figure out that missing side. I feel like we just did this, that set of numbers. I think that's the square root of 8. And then from that drawing, I need to figure out what the sine of theta is. I think the sine of theta is going to be equal to opposite over hypotenuse, -1/3. Okay. The next slide that is circled in the make the triangle and find the ratio problems to do. This concludes 15.1 day 2. We're going to have a short quiz the next time we get together over 15.1. You don't have to do all of these problems, but you should be fairly comfortable working on finding all of the pieces and using trig identities. Okay, great. Have a good day. If I remember correctly, as a challenge, you're welcome to do it. There's nothing on the test that's going to be working with the sources right now. Anything. Okay. Maybe I'll do 162. It looks like the grossest of the bunch. This looks like 2 cosine theta to me. Okay. So I think this is cosine squared theta minus sine squared theta. Well, what's the theta? We need to draw a picture. It says, and it's positive, so I put it in quadrant 1. It says that arc secant. Secant is cousins with cosine. So is 25 over 7, which means cosine is going to be 7 over 25. This is a Pythagorean triplet. If you didn't know that, that's fine. You could use your calculator, but this is a 7, 24, 25 triangle, which means that cosine of that theta is going to be adjacent over hypotenuse squared, of course, and then sine is going to be 24 over 25 squared, and I'll save you the calculator strokes. I did this earlier, and I think you get that. Okay, so that's 162. Give a couple of those a whirl. So for our, look at the next one. This is more of the same, like, I'm not going to do it, but I see that cosine, this is theta 1 plus theta 2, so that looks like a Q. So you're going to draw 2 triangles, right, and mark it, theta 1, theta 2, and then this is cocosine, cosine theta 1 plus, cosine theta 1, cosine theta 2 minus sine theta 1, sine theta 2. And just figure out those triangles and input the numbers into those ratios. That's about, really challenging. I think there's a story problem here. Totally doable. You can do this. Actually, all of these are. The 185 is required. I don't know if I've seen a ton of it. The challenge, I did this challenge and it's okay. Both of these are fairly challenging. And then Doc marked something as super challenge. I have to admit, I didn't do this one.